Hi everyone, in this video I want to talk about simplifying cube roots with and without variables. Here are the two problems that we'll do, and the fun question is, who is your favorite Disney character in the past? Be kind of fun to see all of your answers to that. So before we dive in, let's talk about the math section as a whole. Algebra 2, you'll see a lot of exponents and radicals, including like rational functions. So these two problems, they have cube roots instead of square roots. This whole lesson can be applied to fourth roots, fifth roots, sixth roots. It's all the same thought process. But specifically cube roots and cubes are listed as a standard on the ACT. So here we go. If you are simplifying a square root, for example, let's say 25. We know that that answer is 5 because 5 squared is 120, or not 125. 5 cubed is 125. 5 squared is 25, right? So if I did, though, let's say the square root of 200, that does not have a nice happy whole number answer. So what we have to do is instead take out the biggest perfect square, which is 100. You can also do the factor tree method, but with this being a timed test, we want to do these as fast as we can. So you might as well take out the biggest perfect square because it's a number that basically includes all those smaller factors in one swoop. So you want to do the biggest number possible, and that then becomes 10, and the root 2 can't simplify, so square root of 200 is just 10 root 2. So now how am I figuring out all of these perfect square numbers, for example? Well, 1 squared is 1, 2 squared is 4, and then you just go down the list. It's probably a good idea to go all the way to 10, because some of these, like in that one I just did, you see even up to 100. Even it could go even higher too, but because we're doing cubes, we are going to write those out. 1 cubed is 1, 2 cubed is 8 because it's 2 times 2 times 2. 3 cubed, 27. 4 cubed. So that is the 36 times, I'm sorry, the 16 times 4, which is 64. 5 cubed, 125. 6 cubed, this is the 36, and then times another 6. So some of these, this is where things get to kind of slow down, right? So if you can kind of imagine the 6 is stacking and then a 3 extra, that one's 216. And then right there, I'm not going to give you anything higher than that. So we'll cut it off at that. On this test, you do have a calculator, so you can always go higher if you want to. Okay, so I'm seeing, first of all, that we have the numbers 128 and 250. So just like in this example here, I needed to take out the biggest perfect square. Now for these, we need to take out the biggest perfect cubes possible. Okay. We also have variables going on the second one, so I'm going to write out a few things. X times x is x squared, right? Therefore, x squared square rooted is x. If I did that with x cubed now, x times x times x is x cubed, right? Therefore, if I took x cubed and cube rooted it, I would get back to x. Okay. What happens though if I try to do, say, like the square root of x to the 5th? I'd have to take out a perfect square, and that highest one would be x to the 4th because it's an even number, and then an x would be left over because 4 plus 1 is 5. So my answer to that would be x squared times root x. Now, the biggest perfect cube that can come out of all these numbers would be the following. I can take out from my little list right here, I can take out a 64, but the question is, what do we do with this negative? A lot of people think, oh, if we have a square root of, say, negative 25, we'll kind of use this same example here. That involves I, right? That's an complex number, imaginary number. So we need to basically take out the 25 and then take out the negative 1 separately. This would be 5 times I, which is 5I. So sometimes people think when they see the root and the negative that there's going to be an I involved. But I want you to erase all of that thinking for cube roots because, you know, if we did like x times x equals that negative 25, there is no x that you could use other than an imaginary number that would make that true. But if I was trying to do x times x times x equaling a negative number, say 8, you do get an answer. Negative 2 is that answer for x. So in this case, yeah, we can have a cube root of a negative. And I'm going to take out the biggest perfect cube that goes into 128, just 64. What's left over is a 2, because 64 times 2 is 128. And so this here is just negative 4. And then we have cube root of 2 left over. Okay, so then that's just my final answer. I'm breaking it down into smaller pieces so that I can try to pull out that perfect cube. We're going to do the same thing. There's a negative 5 on the outside here, but then I can break all of these into smaller pieces. So 250, that's a 125. What's left over is 2. And then, gosh, how am I going to take out, like, how do I figure out what times what times what 3 times, is x to the 6th, y squared, and then y to the 8th? I'm going to use that same logic. So if I have x to the 6th, that means that x squared 3 times would be my answer, right? So I'm going to break that off, and that's actually a perfect cube. So that'll be a nice answer. But then we're going to have also the perfect cube root of y squared. And then we're going to have to think about what, sorry, I'm scrunched a little bit here. What is the biggest perfect cube that can come out of z to the 8th? Well, that's the number that would be closest to 8 that is divisible by 3. So that would be z to the 6th. And then how many are left over? There are 2 z's left over because 6 plus 2 is 8. So now we get to consolidate all of this by saying that's negative 5. This is 5. Cube root of 2 stays the same. This is x squared. You can't do anything with that next one. And then this is z squared. And then this one here can't simplify any further. Okay, so we have a whole string of smaller factors. Now we just want to put all the cube roots together and anything on the outside together. So negative 25 x squared z squared times the cube root of 2y squared z squared. Final answer. That was a lot. So I'm going to have you try a few practice problems. And they're very similar to what we just did. Just think about the perfect cubes that can come out of each. Take a second, start them, and then I will show you the answers. All right, here they are. They look pretty similar to the other ones that we had. 4 cube root of 6, and then negative 12 pqr squared times the cube root of 2qr squared. I hope this video helped you in some way, and I love this quote. I want to send you off with this lovely thought. Thankfulness is the quickest path to joy. That is very, very true. So feel free to subscribe if you'd like to keep up with new videos, and leave a comment with your fun question answer, and have a great day.